here we go, right off the bat. We're going to be working on double angle formulas. That's what section 5.3 is going to be about. The first question we have is we want to derive a formula or the identity for sine 2a using the identity for sine a plus a. Okay, now we know that, or we've already seen that sine a plus a is sine a cosine a plus cosine a sine a. Well, right away you can say I have two like terms, right here and right here. So that's going to be 2 sine a cosine a. Thus, we have our double angle, which this is going to be equal to sine 2a. Okay, so here are all the double angle formulas or identities that we'll be using in this section. Find them on your formula sheet. We will be using them often, and here we go. Okay, first question. If sine A is equal to negative 4/5 with A in quadrant 3, find sine of 2A. Well, right away, thinking back to what we just derived, sine of 2A is 2 sine A cosine A. Well, you're saying, okay, we have a sine A, we don't have a cosine A. Well, that's when we draw the picture. So I'm going to make my crosshairs, and now I'm going to make my angle, which is going to be in quadrant 3. And I know I have sine, so I'm going to have a negative 4. Negative 4, and then the 5. And this is going to be a negative 3. That's a very famous triangle. We've seen it many times. So now I'm going to write sine or cosine of A is equal to negative 3. All right. Okay, so now we have cosine A and sine A. So we just plug it in, plug it in. Okay, so we have sine A, which is, or 2 times sine A, which is negative 4/5, and cosine A, which is negative 3/5. 3/5. Now, when we're multiplying fractions, we can just multiply straight across the top, straight across the bottom. It's like 2 over 1. So we're going to end up getting 24 25ths. Okay? So that one's pretty quick. Now let's go to the next one. Okay, once again, sine A is equal to negative 4/5 with A in quadrant 3. Find cosine of 2A. Well, if you look back at your formulas, we only need a sine A to solve with cosine as a double angle. So we're just going to use what we know so we don't mess anything up, even though we've already found that cosine A was equal to negative 3/5 from the previous question. I'm still just going to use sine A because cosine 2A, you only need a cosine A. So cosine 2A is equal to 1 minus 2 sine squared A. That's one of the formulas for cosine. Well, I'm just going to plug in my sine A. So I have 1 minus 2 times negative 4/5 squared. All right, so now it's just do the math and solve. So we have 1 minus 2 times, it'd be 16 25ths. Now that's going to be equal to 1 minus 32 25ths, which is equal to negative 7 25ths. So that's going to be my answer there. Okay, let's keep cruising, see if get you guys doing whatever you want to do. So next question now is, oh, look at that, sine A equal to negative 4/5 again. It's continued from before. But we're working with cotangent. Well, looking back at our formulas, we don't have a cotangent, but we know that cotangent is 1 over tangent. So we're going to just take and use the reciprocal. So cotangent 2a is equal to 1 minus tangent squared a all over 2 times tangent a. Well, from before, we know that we have our triangle in quadrant 3. Our sides are -4, -3, and then 5. Well, tangent is opposite over adjacent. So we have tangent A is equal to 3/4. Oh, sorry, my bad. Harp on me all you want. I just wrote it wrong. Okay, so -4 over -3, or which is equal to 4/3. Okay, now we have tangent A, so let's just plug in what we have. So we have 1 minus 4/3 squared all over 2 times, what is it, 4/3. Okay, so now if we do the math, we end up getting 1 minus 16 over 9, and then also 8 over 3. We do the math, we end by getting -7/20. Okay, so let's keep moving, get you guys doing whatever you want to do. Okay, new one here. So we have cosine x equal to 1 divided by the square root of 5 with x in quadrant 4. So now we want to find cosine 2x. Well, once again, with cosine, we just need we need to know what cosine x is. So we're going to have, looking at the formula sheet, we have cosine 2x is equal to 2 cosine squared x minus 1. Well, we have cosine x right there, so I'm going to just write 2 times 1 over the square root of 5 squared minus 1, which is equal to 2 over the square root of 5, or whoops, they're trying to do too many steps at once here. 1 over the 2 over 5 minus 1, which is equal to -3/5. So that's our answer. Okay? Let's keep on the move on. Okay, now if cosine x is, once again, 1 over the square root of 5 with x in quadrant 4 again, we have sine 2x now. Okay, so we have to think, looking at the formula sheet, let's see here, okay, we know that sine 2x is 2 times sine x cosine x. But we just have cosine x, so we're actually going to have to draw our triangle here. So I'm going to make my crosshairs, and now I'm going to make my triangle. So we're going to be in quadrant 4, so I'm going to go over, down. Cosine, so we know this is going to be 1, square root of 5. And we know that 1 squared plus b squared equals the square root of 5, or I should say 5 is what we're looking for. Since that's since that's 5, this is equal to c squared, so that's actually the square root of 5. So we need b. Well, looking at it, I'm gonna say b is 2, so I can get 1 plus 2 squared equals 5. That's 1 plus 4, okay? So just checking the math there, so we know that this is going to be 2. Now, okay, so we have our opposite side, so I'm gonna write sine of x is equal to negative 2 square root of 5, because we're going down, okay? So now we have our sine x and our cosine x, so we're gonna go 2 times sine x, which is our negative 2 over square root of 5, and that's gonna be multiplied by cosine x, which is 1 over the square root of 5. Okay, so if we just do the math now, we're gonna get negative 4 over 5. Okay, let's keep on going, keep on trucking. Now, okay, we have tangent 4/3 in quadrant 3. We need to find cosine 2 theta. Well, I know with cosine, I only need to find either sine or cosine. So let's draw the picture. We're going to be in quadrant 3. We know my sine is 4 and my cosine is 3. Oh, look at that. The famous angle once again. Or famous triangle, I should say. Those are negative. Sorry about that. All right. Now we need either cosine or sine. So I'm going to just write cosine theta is equal to negative 3 over 5, which our formula for finding the double angle of cosine 2 theta is 2 cosine squared theta minus 1. Well, now we just plug in what we know. So we have 2 times negative 3/5 squared minus 1, which is equal to 18/5 minus 1. Sorry, 18/25 minus 1, which is equal to negative 7/25. Awesome, we're moving right along now. Now we're really cruising and cooking. Okay, same tangent theta, 4/3, so quadrant 3. Now we need secant. Well, the funny thing about secant is it's 1 over cosine 2 theta. Well, from the previous slide, we found cosine 2 theta to be negative 7/25. Well, we know that, and we're going to use it. So we have 1 over negative 7/25. Well, we can just find out what that is actually simplified to, and that's negative 25/7. All right, so those are pretty quick when you've already found your angle or your double angle, I should say. Next page. Okay. Here's where we're getting a little bit different now. We're trying to find exact values, or use exact values to show that each is true. Okay, right away with this one, I see that cosine 60 degrees. I should be, looking at my unit circle, I should think to myself, okay, this is 1/2, okay? Now I have 1 minus 2, well, sine of 30 degrees is equal to 1/2. So I have 2 times 1/2 squared. Well, so 1 minus 1/2 squared is 1/4. Well, 1/4 of 2 is 1/2. So it's going to be 1/2 is your 1 minus 1/2 is equal to 1/2, which is what we want. The same thing there and there. So let's keep moving now. Okay, the next question, we're getting this is kind of the same idea of what we just did. So we're looking at sine 90 degrees. Well, right away you should say, that one's easy, that's just 1. And then sine of 45 degrees. That's just the square root of 2 over 2. Cosine of 48 degrees. The square root of 2 over 2. Which is, so now we just plug those in for sine and cosine. So we have 2 times the square root of 2 over 2 times the square root of 2 over 2. And we do the math. We end up getting, well, it's 2 times 2 over 4, which is equal to 4 over 4, which is equal to 1, which is what we wanted right there. Okay, so those are pretty straightforward. The matter is just looking at what you have and putting in, you know, your unit circle number and then just solving. Okay. Okay, this is a little bit different. We don't really know cosine squared of 15. So we should look at the formula sheet now and think, okay, how should I handle this, or what should I do with this? Well, I can see that cosine 2a is equal to cosine squared a minus sine squared a. This looks like we have an a there, and we have an a there. So we just plug it in, plug it in. So we have cosine 2 times 15 is equal to cosine of 30 degrees, which is equal to what? The square root of 3 over 2. Be thinking coordinates on the unit circle. Okay? The next one here, here's the tricky one. This is the one that people are like, okay, I just look at my formula sheet and I can just match it up with the previous one. But aren't we missing something? Should there be a 2 right there? Well, this is where you have to kind of think outside the box. Where did that 2 go? What happened to that 2? Well, we also know that 2 can be written as a fraction, 2 over 1. Well, since we have nothing here, we assume there's a 1 there. There's 1 over 1. Well, how do we get rid of a 2 so it looks like 1 over 1? Well, we multiply by a half, which is, 2 over 2, which is equal to 1 over 1. Well, that would make sense then, because now we have, if we have 1/2 tangent 2 times the 3 pi over 8, our 2 would disappear because of our lead term right here. So we're going to have 1/2 tangent, and that's going to be 6 pi over 8, which can simplify down to tangent of 3 pi over 4. So now we have 1/2 times, well, we should know that this is -1. So 1/2 times -1 equals -1/2. All right, we're almost done. We have one more to go, one more question. So hang in there with me. Okay, a lot of you are thinking, oh, there's a lot going on here. I don't know if I should use the formula sheet or what I should do. Well, first off, we know that we have, or we're doing double angles. Well, right here we have a double angle. You're saying, no, it's a triple angle. Well, all we have to do is break apart the angles into cosine of 2 theta and then plus theta. Like, oh, okay, and now we're going back to the previous lesson, which was when, kind of like what we started with in the beginning here. We have 2 angles now, okay? So we know this is equal to cosine 2 theta times cosine of theta minus sine of 2 theta times sine of theta. Hold the phone. Look at this right here. We have double angles right there. So now that's going to change. That's going to change what we have again. So cosine 2 theta, I'm going to use 2 cosine squared, 2 cosine squared theta minus 1, and then bring down your cosine theta. The main reason I'm going to use that is I know I need a bunch of cosines here and here. Okay, so now I have minus, well, looking at sine squared theta, or sine, not squared, but 2 theta. I know that this sine, in the back, or should I say, I'll just a second, I'll show you it on the board. Okay, so we have, this is going to be 2 sine theta cosine theta times that last sine. Well, multiplying your sine and sine, I have arrows going all over the place, John Madden going on. So I have sine times sine right there. That's going to give me a sine squared. Well, sine squared theta can be written as 1 minus cosine squared theta. So I'm going to write, with me multiplying this in here, so I just multiplied it to the same spot. If any of you didn't notice that. So I have cosine multiplying by 2 cosine squared theta and cosine times 1. So I'm going to write it as 2 cosine cubed theta minus cosine theta. And then since like I said, sine squared theta is equal to 1 minus cosine squared theta. So I'm going to write that as minus 2 times 1 minus cosine squared theta, and then my cosine theta. Okay, now I'm going to let you guys finish this one, or, it's kind of pretty much just a bunch of multiplying now, and we're simplify. So I'll be checking this in your notes tomorrow. See if you can complete it. If not, we'll go over it on the board for sure and see what we can do. For the rest of the time, or the rest of the day, you guys have a good day. Don't forget about your summary and the home. Have a good one.